Hello everyone and welcome to another video learning with Bahagharing Lexi. And today, what we are going to discuss is all about compound interest. And to be exact with, we are going to find the interest, the maturity value or the final value, and the present value of the compound interest problem. And with this video learning, we are going to master the objective or the competency. And what is our competency? At the end of the session, it is expected that you are going to compute the interest, the maturity value, and the present value of the compound interest problem. And to start with our video learning or to start with our learning endeavor in this today's competency, I do have here a gear up activity. Okay, we are going to use the exponential function competency or what we had learned from our previous discussion about exponential function by matching column A to column B. Now, I have here column A, and this column A we are going to utilize the concept that we learned in exponential function by simplifying the expressions given under column A, and whatever be your answer, you are going to match it to column B. Okay. Let us now check if our answer is correct. Now remember, we are going to simplify the expression in column A by applying the concept of the exponential function that we already learned. And then your answer will be matched to column B, but you are just going to write the letter that corresponds to your answer in column B. Okay, now number one, we do have 1 plus 0.03. And then after that, it will be added. Therefore, we do have 1.03, then raised to the power of 3 or 1.03 cube. And the answer is 1.092727. And that is letter C. Okay. Next, for number 2, we do have 1 plus 0.015. Therefore, that will become 1.015 raised to the power 12. And the answer is 1.195618171. And that is letter B. Okay, for number 3, we do have 1 plus 0.025. And then it is being raised to the 5th power. Therefore, our answer will be letter A. That's correct. 1.13140821. Okay, and the last one, which is 1.005 raised to the power of 24, and the answer will be letter D, which is 1.127159776. Okay. Okay, the concept that we utilize here will be applied in our preceding discussion. And to start with, let's recall the problem about Peter and Jose. But this time, I will be utilizing the concept or the problem of Jose. And let's read. Jose is a working student who wants to save money. If he will deposit 10,000 and will earn a compound interest of 3% per year, how much is the interest and maturity value at the end of 3 years. Now, it is assumed that this is compounded annually. I repeat, Jose wants to save money through depositing 10,000 pesos and will earn a compound interest of 3% per year. And what he wants to know is to find what will be the interest earned at the end of 3 years and what will be the maturity value at the end of 3 years. Moreover, what if he wants to have a compound interest of 750 in 1 year? How much will he deposit? Okay. Now, in the additional problem, it is assumed that Jose wants to have 750 in 1 year as an interest. Therefore, the question here is how much will he deposit so that he will have 750 as an interest after 1 year? Okay. Now, in this problem or in this situation, here are the following problems that we are going to answer. Number one, how much is the compound interest of Jose after 3 years? Number two, how much is the maturity value after 3 years? And number three, how much will be deposited by Jose if he wants to have a compound interest of 750 in 1 year? Okay. And to answer with that problem, let's deal with the formula or the formulas that we are going to utilize so that we can able to answer or respond to the problem given. Now, first, we do have the maturity value or the final amount. If you are looking for the maturity value or the final amount of the compound interest problem. Therefore, this will be our formula. F is equal to P, which is the principal, times the quantity 1 plus I, raised to exponent n. Now, we are going to introduce two different symbols. The previous that we had are R and T, which is the rate and the time. But this time, we do have I and N. Now, what is I and what is N? Now, when we talk about I, this is what we call the periodic rate. Since this is a compound interest and the conversion may be monthly, it can be quarterly, it can be semi-annually, or it can be annually. Therefore, the rate now is what we call the periodic rate, which means the given rate will be divided depending on the type of conversion that we are going to impose in our problem, or what is the problem being given to us. For example, if that is compounded quarterly, therefore, the rate will be divided by 4. If that is compounded semi-annually, therefore, the rate will be divided by 2. If that is monthly, therefore, the rate will be divided by 12. And whatever be the result, that is what we call the periodic rate. Okay? And to find for the periodic rate, we do have I is equal to R divided by M, wherein our R is what we call the nominal rate. Okay, the nominal rate, also known as the rate of interest. But actually, if our conversion or if our conversion or the given problem talks about compounded quarterly, compounded semi-annually, compounded monthly, therefore, we do have what we call the effective rate, which is different from the nominal rate, because effective rate talks about the total accumulated rate for 1 year, unlike with nominal rate, which is the rate annually. Okay? And then we also have the frequency of conversion. When we talk about frequency of conversion, we do have the following. We have annually, that is, the nominal rate is divided by 1, meaning to say the interest will earned once a year. Now, when we talk about semi-annually, therefore, the conversion is 2. Okay? Thus, the rate or the nominal rate will be divided by 2, meaning to say the interest earned will be twice a year. Okay? And then we also have quarterly, meaning to say for every 3 months, there will be an interest earned. Okay? And the rate or the nominal rate will be divided by 4 so that we can have the periodic rate. And last one, we do have monthly, which is every month there will be an interest earned. Okay, therefore, the nominal rate will be divided by 12. Okay, and aside from that, we also have the exponent n. And that is what we call the total number conversion periods. Meaning to say, in a given time frame, how many times will your money generate an interest? It's a frequency, how many times. Okay? Therefore, to find for n, we do have n is equal to the time multiplied by conversion. Okay? Aside from the maturity valued formula, we also have present value. And if we are looking for the present value, we do have P is equal to the maturity value divided by the quantity 1 plus I raised to the power of n. And to find for the compound interest, we do have our formula, maturity value minus the present value. Okay. Now, with these formulas, we are going to answer or respond to the problem of Jose. First, we are going to find for the compound interest earned after 3 years and the maturity value after 3 years. And to start with, first, I will be looking for the maturity value instead of the compound interest. Okay? And we do have the given. P is the 10,000. R, which is the nominal rate, is 3%. Then we also have the conversion, which is 1. Okay, our TIF or the time is 3 years, and we are looking for the maturity value. As always, the R, which is 3%, should be expressed to decimal, and this is 0.03. Okay, and we do have our formula. We have F is equal to P times the quantity 1 plus I raised to the power of n. And then by substitution, we do have n is equal to 3, that is 3 years, times 1, which is m, is equal to 3. On the other hand, for the I, we do have 0.03 divided by 1, which is 0.03. Having the values of n and the I, then we are going to complete now our substitution process, which is 10,000 times the quantity, 1 plus 0.03, close parenthesis, raised to the power of 3. Okay? Then, we are going to get the sum. We have 1 plus 0.03, that will become 1.03. Then cube, get the cube of 1.03. And the answer will be 1.092727. Okay? And then after getting the equivalent value, multiply to 10,000. And that will become 10,927 pesos and 27 centavos. Therefore, Jose are going to receive, or Jose will be receiving 10,927 pesos and 27 centavos at the end of 3 years. Okay. Now, with this final amount, we are going to proceed with how much will be the interest earned by Jose. Okay. Now, here are the given. First, the principal amount is 10,000. Now, the maturity value is 10,927 pesos and 27 centavos. The rate is 3%. Our conversion is 1. Our time is 3 years. Therefore, how much will be the compound interest earned? And to find for the answer, we do have maturity value minus the principal amount, which is by substitution, we do have 10,927.27 minus 10,000. Therefore, our compound interest is equivalent to 927 pesos and 27 centavos at the end of 3 years. As regards to question number 3, which is, what if he wants to have a compound interest of 750 pesos in 1 year? How much will he deposit? Now, to answer with question number 3, or to answer our question number 3, then this will be the given. We have the interest earned is equivalent to 750 pesos. And then the rate is 3%. Conversion is 1. Then the time is 1 year. Okay, therefore, how much will be the principal amount? Okay, now we do have our formula. I divided by the quantity 1 plus I close parenthesis raised to n minus 1. Okay? Now, this formula was arrived or was derived from the formula which is I is equal to the maturity value minus the principal amount. Okay. And then by substitution, 750 all over the quantity 1 plus 0.03 close parenthesis raised to 1 minus 1. First, you have to add 1 plus 0.03 and then raise to 1. Okay, therefore, we do have 750 divided by 1.03 minus 1. Then subtract your denominator. We do have 750 divided by 0.03. Therefore, at the end, our answer will be 25,000 pesos. Meaning to say, if Jose wants to have 750 pesos with a nominal rate of 3% compounded annually within 1 year, he must deposit 25,000 pesos so that he can able to earn 750 pesos in 1 year. Okay, now with this, I hope you're able to learn our concept. And for additional information or for additional exercises, now we are going to proceed in our discussion with illustrative examples. Okay? Now, here is example number 1. We have to learn more. Okay? Given, we do have P is equal to 5,000. Our rate is 6%. Our conversion is 4, meaning to say this is compounded quarterly. Okay? Our time is 3 years and we are looking for the final amount or the maturity value. Okay? I repeat, the given are 5,000 pesos as a principal. The nominal rate is 6%. The conversion is 4, which is quarterly, compounded quarterly. Our time is 3 years. Therefore, how much will be the maturity value after 3 years? And to answer, first express 6% to decimal. Okay, then maturity value will be equal to, okay, we have P times the quantity 1 plus I, close parenthesis, raised to N, and our N will be 3 times 4. That is 3 years times the conversion, which is 4. Therefore, we do have 12. On the other hand, for the periodic rate, we do have 0.06 divided by 4, which is 0.015. And then substitution, we have 5,000 times the quantity 1 plus 0.15, close parenthesis, raised to 12. And then how did we able to get this value? Now simply add 1 plus 0.015 raised to 12. And then this will be the result. Then to find for the maturity value, multiply to 5,000. Therefore, our answer will be 5,978 pesos and 9 centavos. Meaning to say, at the end of 3 years, if you deposit 5,000 with 6% nominal rate, compounded quarterly, you are going to receive 5,978 pesos and 9 centavos. Okay, another example. We do have example number 2. Now, here are the given information. Okay, we have the principal amount is 5,000. The rate of interest is 6%. The conversion is 4, which is quarterly. Then the time is 3 years, and we are looking for the compound interest. Actually, this is a follow-up with problem number 1, which is question number 1. Since we already have our compound interest earned, which is 5,978 pesos and 9 centavos, therefore, we can simply substitute. Okay, and that is 5,978.09 minus 5,000. Therefore, our compound interest is 9,978 pesos and 9 centavos. Okay, now this is the compound interest earned after 3 years with a nominal rate of 6%, compounded quarterly. Okay, now what if we do have this problem? Same thing, we are looking for the compound interest, but this time the given are the following. We do have the principal amount, which is 5,000. The rate is 5%. The conversion is semi-annually, which is 2. Then the time is 2.5 years. And we are looking for the compound interest. Now, without finding the final amount, which is the maturity value, then we can directly proceed by getting the compound interest without passing the computation of the maturity value by using this formula. But first, we are going to express our 5% to decimal, which is 0.05. And this will be our formula. Now, this formula was derived from the formula which is I is equal to the maturity value minus P. Okay? Now, this will be our formula if and only if we do not want to get first the maturity value, then get the difference of the maturity and the present. By using this formula, we can directly get the compound interest. Okay? I is 0.05 divided by 12, which is equivalent to 0.025. Okay? Then for our n, we do have 2.5, which is 2.5 years, times 2, which is 5. Then substitution. We do have 5,000 times, we are going to use the bracket, open parenthesis, 1 plus 0.025, closed parenthesis, raised to 5, minus 1. Okay? Then you have to add this 1, that will become 1.025 raised to 5. And then get the value that will become 1.131408 then minus 1. Thus, we do have 0.131408213. Then after getting the difference, you have to multiply it to 5,000. Therefore, the compound interest after 2.5 years compounded semi-annually with a nominal rate of 5%. Therefore, the answer will be 657 pesos and 4 centavos. Okay? Always provide your peso sign here or the unit or the monetary symbol, which is 657 pesos and 4 centavos. Okay? And to further understand the competency, now let's proceed with example number 4. Here is now the given for problem number 4 or question number 4. Now for question number 4, we are looking for the present value. And to find the answer, first, the given are the maturity value, which is 7,500 pesos. The nominal rate is 6%. M or the conversion is 12. This is converted monthly or compounded monthly. And then the time is 2 years. Okay? And before we proceed with the formula, first, we are going to express our 6% to decimal. Okay? And then here is now our formula in finding for the present value, which is F divided by the quantity 1 plus I, open and close parenthesis, raised to the power of n. Okay? And to find for I, we do have 0.06, that is R divided by 12, which is 0.005. On the other hand, we do have N is equal to 2 years times 12, which is 24. Okay? Then, since we're able to find the value of our I and our N, let's go or let's proceed now with the substitution. We have 7,500 all over 1 plus 0.005 raised to the power of 24. And then get the sum. This is 1 plus 0.005 or 1.005. Okay. Then raised to 24. Okay. Then after that, get the equivalent value of our denominator. Okay, therefore, that will become 1.127159776. Then 7,500 will be divided in our denominator, wherein we're able to get the present value, which is 6,653 and 89 centavos. I repeat, for problem number 4, our present value is 6,653 pesos and 89 centavos. Okay? Now, I hope you're able to learn our competency, finding for the compound interest, finding for the present value, and finding for the maturity value of the compound interest problem. Now, with this, let's recall or recap our formula or the formulas that you are going to use if you are going to deal with compound interest problem. Okay, remember, maturity value is F is equal to P times the quantity 1 plus I, open and close parenthesis, raised to N, wherein to find for N, we do have time times the conversion. To find for the periodic rate, we do have R, which is the nominal rate, divided by M. Okay? And to find for the interest, we do have the formula. The first is the basic formula that we have, maturity value minus the principal. And if in case that the maturity value is not given, therefore, you are going to proceed with another formula if and only if the given is the principal value. And for the compound interest as to the principal amount, meaning to say, if we are looking for the principal amount, okay, the principal amount, therefore, P is equal to I, which is the interest, divided by the quantity 1 plus I, open and close, raised to the power of n minus 1. Or you can have the maturity value divided by the quantity 1 plus I, open and close parenthesis, raised to the power of n. Okay, I repeat, this is for the maturity value, this is for the compound interest formula, and this is for the present value of the compound interest problem. I hope you're able to learn the competency or the competencies involving with finding the maturity value, compound interest, and present value of the compound interest problem. See you in my next video learning episode. God bless everyone.